Folks, welcome you once again to Global Education Zone. In today's episode, I'm going to be teaching us how to draw the end elevation of the frustum of a cylinder. So in this case, basically what we need to draw is the plan of the cylinder first. So as you know, we often draw the plan of the cylinder is a circle because that's the shape of the base. So this shape of the base is actually circular. So I'll draw the circular shape of the base here. So this is circular base. That's it. And then I will proceed to divide it into 12 equal parts. So how to do that? Basically, all you need to do is you first draw the two what are they called again? Diagonals. So this is the horizontal, and then I'm drawing the vertical. So I'll trace it downwards too. So I have to draw the vertical diagonal. Now the next thing is I'll put my open the radius of the same circle, and I'll cut from that the point of those diagonals on the circumference on either side. So on up, down, this one I'll go here, left, right. Also go to the next one, left, up, down, and finally I'll go to the last one, which is right, left. So here we go. Finally, so the next thing to do is to connect these points together. So I'll connect them together, connecting them together. Connecting them together. There we go. So there we have it. Now the next thing to do is to draw the plan. So rather the elevation. So how to do this is basically I'll draw a line, a vertical line above the plan on the edge. So I just need to project one, and then I can draw lines parallel to this one. So but then make it so instead. So I'll draw parallel lines to them. So in my opinion, when you are in technical drawing, you are drawing the most important instruments, in my opinion, they are your what are they called again? The set square and the ruler. They are very important because most of the time we often make use of a lot of parallel lines in technical drawing. So the set square and the ruler, they help you to, they help you to do that. So you can draw any lines in this kind of drawing. This is plain geometry, and it relies heavily on lines, parallel lines, perpendicular lines. So that's why you need your set square, and then you have your 30 degree, 60 degree lines. So these ones are very important, especially in your isometric drawing. So once you miss your angle, you miss that particular property of your drawing, which would have made it accurate. So now the next thing to do is to draw the elevation. This is the front elevation, and this drawing is actually in first angle projection, because as you can see the plan is below and the elevation is right above. So that's one property of front first angle elevation. So now this was supposed to be the outline. This is supposed to be the front elevation, but in this case we call it a frustum. So that means we have a part of the parallel cross section cut through. So then let's cut at an angle. Preferably let's start from this edge and cut downwards. You could cut it down to the opposite edge, but no, let's leave some space. That's how it's often done. You don't cut it totally, so that you can be able to show some properties of your drawing. But if you cut it down totally, that's left for you, it's also acceptable. Now the next thing is to project your these points where this line is projected to the front elevation. So where they touch the truncation or the cut, you are going to project them horizontally to the left. The reason for this is that my what's called again, my end elevation is going to be on the left, so that's why I'm projecting to the left. So now we use the set square, copy the horizontal line, and then go up. And then I'll need to copy this. So you can see this is where it's cut. So from the cuts, left, from the cut again, left. I'm projecting everything leftwards. So this is the center line. So and I'll make use of a center line here. So the short dash lines, construction lines for every other line. So here we go. So this being done, the next stage is for us to draw a 45-degree line at the base, at the bottom left, what's it called again, edge. Let's call it the vertex, bottom left vertex of the front elevation. So this is it. So this is the bottom left. So I'm going to draw a 45-degree line, and this 45-degree line, it is used to transfer your, I'm going to use it to transfer horizontal measurements from the plan to vertical measurement. Now the reason for that is that in technical drawing, when you are drawing elevations, end elevations, you often need to draw your vertical, you project vertical lines. The vertical lines on the end elevation will belong from the plan, and then the horizontal lines will belong from the elevation. So you can say that in this elevation we have our horizontal lines. So these horizontal lines, they are the lines that go from left to right, but vertical lines go from up to down. So just in case you don't know. Now, so we are going to move this. We are going to begin to project those horizontal lines first. We will make them horizontal first, because naturally the plan is meant to be a horizontal portion of the drawing, so they will be in horizontal format first. So that's, you can see they are from left to right now, so actually from rather right to left. So the reason for that 45-degree line is that at the end of the day, I will be able to convert each of these measurements to the vertical plane. So that the reason for why it's 45 is because in a 45-degree in a 45-degree setup, the sides are equal apart from the hypotenuse. So the sides are equal, so it's used when you want to transfer the length without altering their actual length. So now I'm going to transfer each of these divisions upwards, so they are going to intersect these horizontal lines above, this one above. So now I'll do that. So starting from the first one, I can start from anyone though, but it's often convenient to start from the first. Take it like that, just the way it comes. So now we have it. So I actually forgot to project the center line. I will actually do that later. It's easy to forget the center line most of the time. Good. Then that's that. Oh yes, so those are the lines. So finally, let me project the center line. I don't really need to begin to measure again. Just so short, long, short, long, short, long. So that is how a center line is. It's made up of short and long alternation of dashes. Now, the next thing for us to do is to draw the shape of that truncation. Now, in this truncation, you see that let's number 1, 2, 3. The cuts 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, this number 1 is on this part. So now you can see that this truncation is from this up. This is the top part of the truncation, and this is the bottom part. So that means the actual cut will be between these regions. And then from the plan, you can see that the truncation. Okay, we don't have that knowledge yet. So it's only from the front elevation we will know the limits of the truncation. So the next stage is for you to begin to project those parts. So basically it's supposed to look like this. The end elevation is supposed to look like this, exactly like the front elevation. But because of the truncation, that won't be the case. So let me just use a faint line to show that this is how it fundamentally should have looked. But now we have a truncation, we have cut out a part. So because of this part, you know that this part is a slanted part, so it will look like an ellipse. So let's begin to trace the part. Now we have the number 10. At the number 10, we have this number 10 is a middle line, so it will be at here. So we have number 12 and number 11 and 9. So they are here, and they are actually number 11 is from here, so this will be number 11. Am I sure of that? Okay, rather this number 11. Rather, this is number. Then we'll go to number. Yes, number 12. number 12 we have it. Yeah, it's also on this part, so number 12 will be here. Then number 1, tracing it here. Then number 1 also goes here. So you can see if you copy that pattern, you don't actually need to measure everything though. So as I'm doing here, so I'm just I've been able to predict the intersection. So now as I drew in the previous episode, I told you guys that you need to trace in, you need to line in first with your pencil so that you will know where your French curve will follow. So this is the path I want my French curve to follow. So it's often best, because if you just use your French curve like that, your curve might look choppy. It might look like as if it's a combination of unorganized lines. So then I can now thicken them with my French curve. So I'll make sure the French curve follows the pattern. So this part of technical drawing, it takes practice. You have to practice this for some time before you can get used to it. But it's very good. It's a part that can actually earn you marks in your examination if you know your work, basically. So here we go. So and it's best for you to join smaller regions first. So you don't need to join everything at once. You can join them small by small. So at the end of the day, you have a smooth curve when you join everything together. You can see this is smooth enough. Though it's still average. It could be, I could have made it better though, but I don't want to waste too much time on the neatness. So then the last part, I'm looking for a suitable portion. Let me use this inner curve. No, it won't go. Let me use this one at the edge. You can see it's actually a procedure that you need to master. So this is the curve, and then the next thing I'll draw the sides of the end that do not pass through the curve. So this is how it will look when you look at it from this side actually. So this is the arrow. Now because this is in first angle projection, so your right view will be shown on the left and your left view will be shown on the right. So that's something you guys should know. So this, even though this is at the left, it's actually the right side of the object. So that is one thing you should know about first angle elevation. So thanks for watching this video, and I hope to see you next episode. Don't forget to like, share and subscribe to this channel. Thanks for watching.